Have you ever really thought about what's happening under the hood when you drag a window across your Linux desktop, or how it's even possible to launch a graphical app on a server 1,000 miles away and have it just pop up on your screen? It kind of feels like magic, right? Well, today, we're going to pull back the curtain on the Linux GUI. Let's get into it.
So here's the plan. First, we're going to dissect the Linux desktop itself. Look at all the pieces. Then, we'll dive into the core tech that's powered it for decades, X11, and the absolutely crucial display variable. After that, we'll see how to run those remote GUIs the modern, secure way. And finally, we'll take a peek into the future with Wayland.
All right, first up, let's talk about the anatomy of the Linux desktop. We see it, we click on it, we use it every single day, but what are the individual parts that have to work together to make it all seem so seamless?
This is the big question we're tackling today. How can an application running on some server in a data center show its windows on your screen right here, right now? It seriously feels impossible, but I promise you, by the end of this, you'll see it's not magic at all, just some really, really clever engineering. It all begins right here. The very first graphical thing you see when you boot up your Linux machine is this login screen. But this isn't just a simple password box. It's actually a dedicated program called the Display Manager, and its one and only job is to handle your login and kick off your desktop session. So let's break down the key players here. You've got the Display Manager, like GDM or LightDM, which just handles that login screen. Simple enough. Once you're logged in, the desktop environment takes over. This is the whole shebang, think GNOME or KDE, with all the panels, icons, and menus. But the real unsung hero here is the Window Manager. It's the piece that's actually in charge of every single window, how you move it, resize it, and close it. They're all different parts of the same team.
And here's how that team works together. You punch in your password at the Display Manager. That fires up your chosen desktop environment. And from that moment on, every app you launch is being juggled and managed by the Window Manager. It's a pretty logical chain of command when you see it laid out.
So that's what we see on the surface, but what's the deep down technology that makes this all possible? Well, for decades, the answer has been the X Windows system, or as pretty much everyone calls it, X11. X11 has been the absolute bedrock of the Linux GUI for ages. I mean, this technology was developed at MIT way back in the 80s, and it was founded on a really revolutionary idea. What if you separated the application itself from the hardware that actually draws it on a screen? And the way they did that was with something called a client-server model.
Now this is the part that can feel a little backwards, so stick with me. The X server is the program running on your local computer, the one that's physically connected to your screen, your keyboard, your mouse. It serves the graphics. The X client, well, that's just the application like Firefox or your terminal. The client just sends requests like, hey, draw me a window over here. And the server does the actual work of putting pixels on the screen.
And because the client and the server are just two separate programs talking to each other, they don't have to be on the same machine. This is a concept called network transparency, and it is the absolute killer feature of X11. This is the secret sauce. This is what makes running a graphical app from another computer possible.
Okay, but if an application can send its graphics anywhere on a network, how does it possibly know where to send them? Well, that brings us to a critical little piece of this whole puzzle, the display environment variable.
The best way to think about the display variable is that it's like a mailing address for your graphics. Every single GUI application, before it does anything else, checks this variable to find out where it's supposed to send its windows. If that address is wrong, or if it's missing entirely, the app has no idea where to go, and you see nothing.
The full format is hostname.displayscreen. But for a regular local desktop session, the hostname part isn't needed, so it usually just defaults to 0. That's just a shorthand way of saying the first display on this very machine. In fact, if you pop open a terminal right now and type echo $display, I'm willing to bet that's exactly what you'll see.
But now watch this. When you use SSH to do X forwarding, that variable suddenly changes to something like localhost 10.0. This is telling the remote application, hey, don't send your graphics to a physical screen here. Send them back through the secured tunnel that SSH created. And this is why if that display variable is ever misconfigured, you get that infamous error that every Linux user has seen at some point, cannot open display. Okay, let's put all this theory into practice. How do we actually use this to run graphical apps from a remote machine, but do it the modern, secure way?
With SSH, this is actually incredibly simple. On the server, you just have to make sure X11 forwarding is enabled in its configuration. Then, from your computer, you just connect like you normally would, but you add a -X flag to the command. That's it. SSH automatically handles everything else. It sets up the secure tunnel, it configures the display variable on the other end, and boom, any GUI app you launch in that terminal just shows up on your local desktop.
And here's why this is really the only way you should do this anymore: security. The entire graphical conversation between the app and your screen is wrapped up inside that encrypted SSH connection. This makes older, frankly dangerous tools like Xhost completely obsolete. You no longer have to blindly trust traffic from an IP address. Everything is locked down and secure.
So for decades, X11 has been the undisputed king of the castle. But let's be honest, its age is starting to show. So now it's time to talk about what's coming next for the Linux GUI.
And that's the big question, right? An architecture designed in the 1980s carries a lot of old baggage. It was never designed for the super smooth animations, the high-resolution screens, and the modern security threats we deal with today. The community's answer to this problem is Wayland.
So what exactly is Wayland? It's a modern display protocol designed to replace X11 with something that's just simpler and more secure. Its biggest architectural change is that it basically merges the display server and the compositor into one thing. You remember the window manager we talked about? The compositor is kind of its modern cousin. By combining these jobs, Wayland gets rid of a huge amount of complexity, and it patches up a lot of the security holes that were just part of the old X11 model.
This table really nails the key differences. X11 has that complex, separate client-server model. Wayland just integrates it all. But the security point is absolutely critical. In X11, one app could theoretically snoop on the keystrokes you're typing into a completely different app. Wayland was designed from the ground up to prevent that by keeping all applications isolated from each other. And of course, it moves on from the old display variable to its own, Wayland display.
So let's do a quick recap of what we've learned. A Linux desktop isn't just one monolithic thing. It's a system of different components all working together. For years, its core has been X11, whose client-server model and the display variable make powerful remote GUIs possible. We know that the secure, modern way to do this with SSH-X. And finally, we've seen that the future is Wayland, which promises a simpler and much more secure foundation for our desktops. And that brings us to a final, pretty interesting question to think about. Wayland's design is all about prioritizing security and simplicity on your local machine. But that very same design makes the easy network transparency of X11 a lot harder to pull off. So, as more and more of the Linux world adopts Wayland, what's going to happen to remote GUIs? That's a challenge the community is actively trying to solve right now, and that story is still being written. Thanks for watching.